Flood Control Project. Here's a sample overview for term paper presentation purposes. I chose the project Rehabilitation of LAMO Flood Control and was overwhelmed to find out that it was the biggest 2015 provincial flood control structure using the 2013 5% Calamity Fund. It consists of 192 meters long rubble concrete structure equivalent to 3,269.45 cubic meters and rechanneling of riverbed of about 187.50 meters long or equivalent to 1,983.63 cubic meters. It is located at Tupac del Norte, Nueva Vizcaya, where there were frequent flood issues among residents living near the area. It was then subjected to structural rehabilitation. By Google Map, the site can be seen alongside DM Junction Malasin Road. Shown on the upper left side is a preview of the said road, and on the upper right is the prepared plan. The baseline duration was estimated 82 calendar days. Mode of implementation was by contract. Appropriation was 10 million pesos. Approved program of works are as follows, checked and signed by the respective authorities. Included here are the engineering essentials derived during the planning phase of the project. We have Step 1. Site inspection, or also called as field inspection. Step 2 is plot. Other data on site were recorded and transformed into drawing plan. A sample preview is shown where it consists of plans, elevations, cross-sections, and profile as per code and DPWH flood control structure standards. Step 3 is programming. This includes essential attachments such as detailed quantity cost, unit cost derivation, transshipment cost, bar chart, manpower, equipment schedule, and the network diagram, or for example, is the per CPM. Important parts are also the work item cost estimate, program of works, and scope of works. This is where we discuss the details of the project by description and by value. For example, we take paylist item code 507 with a paylist description of rubble concrete 3,269 cubic meters. Work includes the watering of structure bedding using water pump, laying of boulders for rubble concrete, mixing of concrete using concrete mixer, and pouring of Class B concrete at every layer of stone and compacted using concrete vibrator. Whereas specifications are as follows. Schedule. As part of the planning phase, a schedule for duration, manpower, equipment, and network diagram were also prepared. First, shown here is a bar chart with a combination of percent weight S-curve. The bar chart reflects a sequence of activities with corresponding duration days. The coordinate serves as the plot limit for this schedule format. An item starts or proceeds depending on its predecessor coordinate and ends with its successor coordinate. For this project schedule, there was a need for rechanneling to divert the flow of water before structure excavation. During the first month, it is expected that this item is almost finished and at least rubble concrete is started. The work stretches as it meets its end duration. It can be seen from the bar chart that the maximum successor coordinate is 68. This is then multiplied by an allowance factor 1 1/5 to address unforeseen issues affecting the baseline duration. An S-curve is also showing the essential data such as percent by item weight and S-curve equation. The R-square for most S-curve project schedule must satisfy that it must not be greater than 1. The equation is also provided for some special case to determine a specific percent weight of an item versus a specific date. This is used to tell the cash equivalent. The percent weight multiplied by the approved budget contract. Manpower schedule. Manpower schedule. Plotted here is a bar chart similar to duration project schedule, but unlike the previous schedule, this highlights the quantity of crew workers versus time. The red mark indicates the critical number of crews in a specific time span. Equipment schedule. Equipment schedule is same as true with manpower schedule, but this is more on quantity of equipment. The red mark also states the critical number of equipment in a specific time span. Network diagram. The network diagram is based from the format and data shown. A WBS code is added beside the work items to satisfy the format. This project network diagram is plotted to show the sequence of activities similar to bar chart. It starts with rechanneling with an item code of SPL1, WBS code of 3, duration of 4 days, and percent weight of 1.12%, predecessor coordinate of 0 and successor coordinate of 4. Simultaneous with this work item is the tarpaulin signboard, which must last only for a day. Succeeding the SPL1 item is structure excavation, then rubble concrete. The red mark indicates the critical path. FS is finish start, and SS is start to start. Bidding. The bidding procedure conforms to the 2016 revised IRRR of Republic Act 9184. Construction process. The construction process, sometimes called the construction stage, is the physical process of building, landscaping, or refurbishing plus all the associated activities such as demolition, site clearance, administration, and so on. Construction works are typically carried out by contractors. The process may start following a procurement process, with handover of the site from the client to the contractor and end with a handing back a completed project to the client. Evaluation. After certification of practical completion, it followed by defects liability period, during which any defect that become apparent may be rectified by the contractor. The contractor may still be liable for damages for breach contract or negligence after the defects liability period if latent defects become apparent. As of now, there were no reported cases of defects and the structure is still in significant use for the residents nearby. Flood have been an integral part of human experience. A flood is an overflow of a large amount of water beyond its normal limits, especially over what is normally dry land. Flooding causes many impacts. They damage property and endanger the lives of humans and other living things. Some high and prolonged floods can compromise vehicle traffic in areas that do not have elevated roads. Flooding can interfere with drainage and economic land use, as well as with agriculture. Structural damage can occur in bridge pillars, sewage systems, and other structures in the area of floods. Water navigation and hydroelectric power are often hampered. Financial losses due to floods are typically of millions of financial budget each year. Flooding may be caused by many factors such as intense rainfall, strong winds over water, unusual high tides, tsunamis or failure of dams, elevation of retention pond levels, or other structures that contain water. During periods of rain, some of the water is retained in ponds or soil, others are absorbed by grass and vegetation, some evaporate, and the rest travels over the land as surface runoff. The main causes of flood can be grouped into two types: natural causes and two man-made causes. The important natural causes of floods are prolonged rainfall, high-intensity rainfall, meandering passage of rivers, blockage of river passage, high tides, storm surge, or tsunami coastal area. Man-made causes. The important man-made causes are construction work, urbanization, alteration of river passage, construction of bridges and storage bodies, deforestation, and farming. To plan for floods, you need to understand the type or types of flood you may face. Why? There are several different kinds of flood, and each one bears a different impact in terms of how it occurs, how it forecasts, the damage it causes, and the type of protection you need. Fluvial floods, river floods. A fluvial or river flood occurs when the water level in a river, lake, or stream rises and overflows onto the surrounding banks, shores, and neighboring land. The water level rise could be due to excessive rain or snowmelt. The damage from a river flood can be widespread as the overflow affects smaller rivers downstreams, which can cause dams and dikes to break and swamp nearby areas. Pluvial floods, flash floods, and surface water. A pluvial flood occurs when an extreme rainfall event creates a flood independent of an overflowing water body. A common misconception about the flood is that you must be located near a body of water to be at risk. Yet, fluvial flooding can happen in any location, urban or rural, even in areas with no water bodies in the vicinity. There are two common types of fluvial flooding: surface water floods and flash floods. Coastal flood or storm surge. Coastal flooding is the inundation of land areas along the coast of seawater. Common causes of coastal flooding are intense windstorm events occurring at the same time as high tide or storm surge and tsunamis. Engineering in action. The engineering works that can prevent and mitigate the effects of floods are as follows. On highways, the implantation of steel pipes should take water by gravity away from the road from the catchment basins. 2. The severe flooding problems in a city that paved much of its soil would be alleviated in part by the construction of great swimming pools that are large underground water tanks to store the waters. 3. Mandatory placement of permeable drainage floors in huge courtyards of parking lots in malls, supermarkets, and cinemas to allow the water infiltration in part of the ground being the same for monuments and spaces around buildings. 4. Using drains and gutters around all houses to divert rainwater to a reservoir or disposal area. 5. Maintenance, whenever possible, of some green areas so that the water is reabsorbed by the soil. 6. Rectification of rivers and streams, construction of dams and canals in large rivers that extend their containment basins. And 7. Implementation of a civil defense system that should be able to at least warn people and have a scheme to remove them from homes in time with some belongings and accommodate them. Community in action. Caring to avoid flooding in urban areas is as follows. Keeping streets and sidewalks always clean. 2. Cleaning and unclogging manhole and storm drain. 3. Keeping in the house the channels and other channels of rainfall free of branches and leaves of trees to avoid clogging and consequently return of water. 4. Putting garbage bags on sidewalk only near the time the garbage collection truck will come, preventing them from being drawn into the manhole when it rains. 5. Having a drain pump on hand if flooding cannot be avoided. 6. Using Dutch and British flood-proof technology as a floating amphibian house that allows buildings to float in the same way as a boat. The reference and sources used in this short report are as follows. Flood Control Project.